Last time on the Vintage Collector, failures on writing to the flash. I bricked it. No! And now for the conclusion.
And so I bricked this Cobalt RaQ 3 server. But with the recovery CD at my disposal as an ISO file, maybe I can emulate it in VirtualBox.
Have you ever fixed an old computer? I did, many times. I'm the Vintage Collector and these are my stories. So after I bricked the Cobalt RaQ 3 machine, I was thinking if it were possible to run the Cobalt OS in a virtual machine in order to play around with it. And as noted in my original video about the RaQ 3, I could get my hands onto some ISO images, so it should be possible to bootstrap it properly. I went then to create two VMs in VirtualBox. I started off with the one called Bootstrap. It's important to choose Linux 2.2 here for the best OS compatibility. As the Bootstrap VM needs only to boot off the ISO file, I skipped creating a virtual hard drive. I would however go to customize the network settings and switch it from NOT to an internal network and attach it to a new network being called Cobalt 1. And finally, I'd attach the ISO file to the virtual CD drive. For the second VM, which is supposed to emulate the Cobalt RaQ 3, hence the name Cobalt Emulation, I was creating it using pretty much the same settings, with the only notable difference being the creation of a 10GB virtual hard drive. I then powered on the Bootstrap VM, which booted directly into the ISO, eventually ending up on this status screen here, directing me with the further steps to be carried out on the Cobalt RaQ 3. I was then firing up the emulation VM and directed it into the boot menu by pressing F12 and then selecting the network boot option. However, it would never get as far as I had thought, as the VM would always end up on the DHCP timeout. It could well be a network problem, though it may as well be the Cobalt actually using boot P in favor to DHCP. I should be investigating the ISO file to prove that claim. Though, even if it were boot P, I would need to create a boot image containing a boot P loader for the bootstrap. But even if I did so, it would ultimately not help me at all, as I'm pursuing a dead end here. There's two things that make me rethink. For one, I have to use the physical console buttons on the device during the setup. As I'm running in a VM here, that's totally not possible. Now, the Cobalt offered the option to connect the serial console and use this instead of the front panel buttons and the LCD. But the catch is, this was built into the firmware, so it's out of question here. So I need to do a different approach, which involved creating yet another VM. This time over, I provided it with some 2GB of RAM and also added a second virtual CD-ROM drive. My idea this time, booting up using a live Linux and see if I could use this to bootstrap the Cobalt OS. The Cobalt OS was essentially not much else than a customized Red Hat Linux 6. Not to be mistaken with Red Hat Enterprise Linux, which only came in a few years later. Now, I had a hard time finding this historic release online, but eventually I found Red Hat Linux 6.2 on archive.org. Though, without going into too many details here, my attempts in bootstrapping from the install CD was a fail. So I ultimately turned to using an old release of the KNOPPIX live distro, release 3.7 to be exact. Even though it's Debian and not Red Hat based, it should be good enough. Once booted, I was having a first look at the Cobalt ISO, which was mounted at /mount/CD-ROM1. Well, it gives me some ideas already, so let's dig deeper. And here comes the proof of my assumption, as I was looking into the /etc/dhcpd.conf file of the Cobalt Restore CD. See here how it has the keyword set to allow servicing boot P requests. This tells me my previous arguments about the missing serial console and the missing front panel keys are still correct. Hence, even with the VM getting a DHCP address, it would not have helped me. The dhcbd conf is actually missing the boot file-name configuration statement, so it's definitely not intended to support booting via DHCP and PXE. Having the dynamic bootp statement in there, on the other hand, seems very indicative for Cobalt Networks having made use of the bootp protocol instead. So I'm sticking to my previous decision to see if I could perform the installation by other means. So I'm running the find command here to have it reveal any RPM package files contained on the recovery CD. And see, there's many of those found beneath the /live/nfsroot-x86 directory. This tells me yet another thing. When the Cobalt RaQ was booted via the network, it would actually mount its root file system from the recovery server via NFS. Hence, if I'm doing a change root inside this nfsroot-x86 directory, I may actually be able to run the installation procedure. So I continue my inspection into that directory, where I find the 3000R_3.148 directory, which was revealed to me via the find command as well. Having another look inside, I find here a directory being named installer, and also another one by the name of scripts. As the Cobalt RaQ only performed headless installs, I'm pretty much certain now to find in there what I need. A bunch of scripts which I can use to run the setup myself. In the worst case, I have to extract the command sequences myself and run them one by one, but I'm really confident here. Watch this, Cobalt_install beneath the installer directory. Now this is really promising. Oh yes, while it is not too descriptive, but up there is already some runtime variables which are preset. And here it's obviously tinkering around with the fdisk and fs tab. And even more's inside, like adding some template config files and creating directories as it's mentioned for the RPM installation. These lines here clearly are related to retrieve the packaging list of the RPMs and then process them in a loop one by one. At the end, there's some cleanup performed before the installation finishes. I definitely have struck gold here. Now I only need to find out the exact parameters for calling that shell script correctly. I start by checking those vars and trying to make up the command myself. I grab through both the Cobalt_installer script but also this source lib file by the name of ifuncs. Eventually I came up with something like this, which I simply ran to see what happened.
On a side note, maybe you should run this from within a change root.
Ah yes, good catch. A change root is definitely the better idea when looking at those error messages. So basically, here's the commands to enter the change root. It's as important to create a tempfs for /temp as we're running off a read-only ISO file here. Also, def and proc must be mounted before the final change root call. To kick it off, then change to the 3000R_3.148/installer directory. During my investigations, I was reverse engineering the various startup scripts and found out that you don't need to call the Cobalt_install script directly. Instead, the build_release script must be called with the parameters as shown. It will then call Cobalt_install internally, which in turn will format the drive and also perform the package installation. Don't worry, you'll see many errors about the absent LCD during the installation. Also, there's other errors seen, like this quota failure. This is expected as I'm running this from the KNOPPIX change root, so some services are not running and the LCD in particular is of course missing. At the very end, this sequence of being the Lyle super hack is run. It made me curious, so I went down into the ifuncs shell library to find that function, including some annotations here. Well, after all, it really looks like a super hack to make things work. The post-install cleanup actually took several minutes, and eventually you'll find even more error message on display. Just ignore them, as again, this is expected as you're not running in the real environment here. I'd then go for the first reboot of the freshly installed hard drive, just to run into the first problem. BIOS says there's no bootable medium. And of course, it's not bootable. Silly me. Even in my last video about the Cobalt RaQ, I mentioned the custom firmware that was used instead of a traditional BIOS. Now, this custom firmware could just do one thing for booting. It looked for an extended to revision 0 partition located /vmlinux.gc and booted that. There was no additional bootloader needed. Now, this is a VirtualBox VM coming along with a BIOS, so things of course are a bit different. So I need to install a bootloader. So back on KNOPPIX, I mounted /dev/hda1 again to /mount target, essentially also creating a new directory at /mount/target/boot/grub. There I added this menu.list file, directing it to /boot/vmlinux.gc and also giving it some additional kernel boot parameters. I then installed grub and rebooted the machine again. So the boot menu appeared, which is some progress. But on selecting the boot entry, I'd end up with this invalid executable file format error. And this stayed like this, even when hacking in the boot command line myself. Here I'm back on KNOPPIX, mounting the root partition again. I want to have a look at the kernel. It's in compressed format, so I'll uncompress it quickly. The file command now reveals something odd at first, telling me it's actually an ELF 32-bit executable. This by itself is totally correct, but I haven't seen this for a long time in my life. Typically, the Linux kernel is built as a boot image, with the make commands being make bcimage or make cimage. This would concatenate the kernel with a boot sector, which in turn can be called off from a boot manager like Lilo or Grub. Such a boot image would then also report as an x86 boot sector from the file command, and not like this one, a stripped down bare metal ELF executable. However, the Cobalt RaQ and Cube machines originally were coming with a custom firmware instead of a traditional BIOS likewise. With the Cobalt firmware, which expects an extended 2 partition with the vmlinux.gc file being present, it seems to just chain load the kernel directly. Had the Cobalt been a real x86 machine with a regular BIOS, it would have made not much sense. So I believe finding this stripped down kernel is a relic which was ultimately inherited over to the x86 machines. And while it would be possible to chain load this kernel, I ultimately gave up and went into recompiling a new kernel for the reasons explained in a moment. By default, both the kernel headers and the kernel source are installed, along with the compilers and linkers. The kernel source is found, as usual, at /user/source/linux, though my first attempt at compiling the kernel would bail out when trying on the SCSI support. I was then lazily disabling SCSI support in the kernel's menu config and then trying again. This will progress farther, though ultimately fail again due to a missing AS86 assembler. In my previous video, I noted about that one single server I found that still held a copy of the Cobalt FTP servers. At first, I was looking at these directories, if I could find the missing package, namely the def86 containing AS86. Besides that, Cobalt OS didn't include the package for the Lilo bootloader. So ultimately, I took the Red Hat Linux 6.2 RPMs for both packages and transferred them over to the target partition. From the mirror of the Cobalt FTP server, I also took the kernel source package for the 2.2.12c5 release, just in case. I would then briefly install the Lilo and def86 packages into the change root. And despite the error shown, the package installation completes, leaving me with both Lilo and AS86 available. So let's try again if the kernel compile succeeds this time over. And it seems to be alright this time round. So I'm installing the rebuilt kernel modules. I'll be also copying the BC image manually to /boot and also be creating a lilo.conf in order to install the bootloader. Oops, file not found. I had the intention to actually name the kernel with the version tag, in case I'd be playing around with other kernel versions, so I rename it quickly and… still a typo here. Good, that's it. I shall reboot it now. Let's see what happens. What? Not bootable again? Really? Okay, let's do it again with installing Lilo. I overlooked this one. The partition was not marked active. Let's fix it. Still not working. Can you see it? I was hacking in /dev/hda1 to install Lilo2, but actually it should just read /dev/hda. Alright, now we're talking. Lilo comes up and starts the kernel, but somehow there's no console output. Now, I was also adding a rescue entry to Lilo, so Linux would boot just into a shell. Let's try this one. No output. Listen, I'm going to bed now. I need a fresh mind.
And this concludes my look into making…
Wait a second. Nothing is concluded here. I let it run overnight, and it looks still the same the day after. I had an idea what to check while being in my dreams. Let's go and check the kernel configuration for the text console settings. Yes, here it is. The text console was disabled on purpose. Valid point, as the Cobalt RaQs didn't come with a graphics card but a serial console. Maybe I could have hooked up myself to the VM serial line as well, but I actually prefer to have a VTY text console, so I'm up to recompiling the kernel once again. Oh wow, look at this beautiful console output. And it's running a file system check now. Alright, even after 1 hour, the VM would not get any further and being still somewhat stuck at the file system's check. I'm trying quickly if I can access the root shell by means of the Cobalt OS rescue boot entry that I also had created. Alright, that seems to work. At least I can boot into it. Let's do the file system check. E2FSCK is not in the path. Yeah, makes sense, /bin/e2fsck should do it. Unless I'm keeping the typos in, of course. So I'm looking around in /etc/rc.d if I can spot where the e2fsck is run from. And here it is, most likely that RC.SYSINIT script. To me that looks totally correct. I don't see at the moment why it should fail. Let's give it another shot. Okay, again. It's stuck on the file system check. At least I can boot into that init root shell. This is really helpful. I'm going to do something ugly now, spamming the script with some echo commands to better understand what's happening. So if that's the output line for the root file system check, I'm adding a brief diag output just after, which should also print me the return code. That didn't seem to make any difference. Why is the FSCK stuck on boot when it runs perfectly fine from my root shell? Alright, so I'm adding here the command as an output to see what actually is being called. And on the next reboot I see this actual command appearing here, so I'm definitely in the right spot. But again, the E2FSCK seems to be stuck, as it never returns, so it doesn't end up on my next line diagnostics output. The only difference to what I was doing is that the init script runs FSCK while I run E2FSCK. Let's see if I can replicate this misbehavior. What? So I'm running the same command as the init script and it works? That totally doesn't make any sense to me. I'm briefly looking at the file type, suspecting it's maybe a weird shell script, but no, it's an ELF binary. Maybe the strings of the binary reveal something already, but no. To me, it looks totally legit. Maybe I should do an object dump on it. So I'm randomly gazing through with object dump and strings to see if I stumble across something obvious. But I need to dig deeper. This brief look didn't lead me anywhere. But before doing that, I try it differently. I hack in e2fsck into the RC.SYSINIT and try again. Alright, still stuck. Let's try in the root shell. E2fsck wouldn't accept the /t argument. But that's odd. I should have actually seen an error during the previous boot complaining about the wrong command line arguments. Okay, I wasn't paying attention when blindly hacking in some debug stuff into that script. I adapted it now to read correctly with the existing logic. Still, I should have seen my own output, which was totally not the case. And still, even now with this change, it's again stuck. I'm looking at the RC.SYSINIT script once again. And I'm also looking at this init function's shell include. Okay, I have a stomach feeling now. There's some appearances of the LCD related commands like LCD stop and LCD swrite. Can it be that these commands lock it up somehow? Like the RaQs didn't have only the serial console, but also the LCD for text output. And it's not actually the FSCK being stuck, but the output redirection. The init script then pointed me at the LCD-stop utility. Now, this doesn't seem to do anything, but look here, calling up LCD-write seems to lock up. Yeah, I'm pretty sure now. Not the FSCK utility is the issue, but the output redirection. Oh yes, look at this! I was not spotting that before, but it seems to make sense now. The LCD swrite has the ampersand at the end, so it's sent to background. I wouldn't be surprised if this does just one thing, capturing or waiting for the console output and sending status updates to the LCD. And now that the LCD is missing in the VM, it locks up. And there's many more of these occurrences in any of the init scripts. And this is always calling up for those LCD related binaries. I have no intention to patch this out from all the scripts. Maybe I can try something simpler here, like moving the LCD binaries away. So I'm doing exactly this. I create a new LCD tools directory in /sbin/LCD tools. Then I'm moving all the binaries into that directory. As these binaries are referenced all over the place, I'm just creating some symlinks from /bin/true for the original file names in /sbin. This will prevent random file not found errors. Let's see if that makes a difference already. Oh yes, totally, that was it. We're still getting some errors, but it's already a giant leap forward. But now, I seem to be stuck again on the network configuration. So one thing at a time. Here we have various errors on the kernel module symbols. There's also an error about an onset hostname. And modprobe complaining about not finding the bandwidth module and then the missing network interface ETH0. Okay, I'm going to look at the kernel modules first. Something that's a bit odd is that the source is 2.2.12c3, but it reports as 2.2.12c2 and also installs the modules into /lib/modules/linux-2.2.12c2. And depmod reveals invalid symbols, which typically comes when kernel modules versioning is in place. Well, for the moment, I'm simply gonna turn this off and recompile everything once again. I just want to get it to work in the first place. Don't forget to reinstall Lilo whenever you have a new kernel, as the bitmap must be updated. Now I start by the root shell first to see if depmod is still throwing errors. Nope, it's not. Good. But look, I'm trying to locate that bandwidth management module. I struggled to finding that file, but eventually bwmgmt.o it is. But look, here again this weird mismatch on the 2.2.12c3 and the 2.2.12c2. that module made it into a different directory. I think I'm going to try with that other kernel source for 2.2.12c5 that I had downloaded before. I need to fix this mess. Oh no, I have the dependency to the kernel headers and I forgot to copy that file. Let's see if I can fix this. Alright, so installing these two RPM files, it now complains about a conflict with the SCSI headers. Did I now actually stumble across the reason for that previous build failure on the SCSI support? Well, I ask RPM to force the installation anyway. Then I'm repointing /user/source/linux to the 2.2.12c5 directory. And from here on, I'll be switching on the VGA console and disabling the kernel module versioning. But I leave the SCSI support in, and it seems to compile all fine this time over. I'm also adding the new kernel in parallel to the old ones to lilo.conf. Upon the next reboot, now depmod no longer reports errors, and also I can successfully load the PCNet32 module, which is needed for the network support. Now, since this is different from the default network interfaces found on a real Cobalt RaQ3, I'm adding an alias for ETH0 to PCNet32 in /etc/modules.conf. The next reboot would then successfully load the PCNet32 kernel module, but, well, what? I'm stuck again? Once again, it's a stomach feeling driving me ahead here. I'm gazing through the kernel configuration and eventually I stumble across this interesting bit here, though I was not looking for it actually. What is the Cobalt Networks bootloader? Remember me talking about the ELF kernel previously? Can it be that using this option here actually builds, may I say, the other missing half, which would be required to make it work with the real Cobalt machine? It's totally irrelevant for now, as I'm dealing with the VM setup here, but may be worthwhile to drill down to fully understand how the bootstrapping really works. But let's focus on what I am after. I'm still suspecting more woes about the Cobalt specifics, and here, beneath the character device, I finally find another something. Let's disable the LCD support in the kernel, shall we? Alright, now with the kernel having the LCD support disabled, I actually got a lot further in the boot process. And look here, here's an error about the char major 10140. I wouldn't be surprised if that's actually the device node for the LCD panel. And there's some errors still related to the network config, which still deems incomplete. And finally, here we are at the end of the system init, which denotes an error with process 1 respawning too fast. I think init is trying to fire up a VTY console here. Coming from the previous statements, this machine's originally not having a VGA console, I need to briefly check into /etc/init tab. It is exactly what I suspected. The system console was configured to run on the TTY S0, so the first serial port. I'm changing that to fire up on TTY1 instead. Also, I'm re-enabling the virtual consoles on TTY2 through TTY6. Wonderful! Now we have a virtual terminal on VTY1. The only problem is, I don't have a password. Or do I? Back in the days, the Cobalt RaQs always had the default username admin, with admin also being the default password. And it totally works like that. So let's poke around the system a bit. No sudo, but su will do. Okay, so the network init didn't work. I'm missing the DHC client here. Well, after all, that sort of makes sense, as these machines are server appliances, so they would preferably run with static IP addressing. So let's adapt that briefly so I can properly bring up the system. What? Now that I have a running OS, I wanted to properly shut down and reboot, but I get this weird error message here. The message refers to some Cobalt specific routine, which is probably hardware dependent as well. I guess I need to tamper around with the kernel again. And so here I am going to remove the Cobalt RaQ support altogether. But instead I'm enabling the advanced power management. I'm pretty certain here that this will fix the previous issue. Oh wow, that was now really fast. We're coming for the ultimate moment of truth. Will I be able to access the management UI via the web browser? On accessing the web page, something is happening, eventually showing me some broken links. Well, I know from the past the admin UI runs on port 81, so I jumped for the URL on port 81 right away. I love this! Gonna start the setup wizard now. Here you add the new admin credentials and the initial settings. You can even opt to register your virtual Cobalt, but since Cobalt Networks and Sun Microsystems are long gone, there's not much point in it. Well, the system will now use links everywhere matching up for the hostname rac3.cobalt.local as previously defined. Now this will cause some issues when you want to play around, so either you register that in your local DNS or within the /etc/host on Unix-like systems or here for Windows. This will make the hostname resolution work, so it's therefore easier to access the web UI without any hassles for further configuration.
Well, that's it. I'm done. It turned out to be way more work than I had initially expected, and sometimes it really felt like, what am I doing here? But hey, if you have ever wanted to play around with the Cobalt OS and couldn't get hold of a real Cobalt RaQ 3 server, or, like me, have bricked it, here's the solution. I'll be uploading some build instructions to GitHub, and if time permits, it shall be available at the time this video comes out. Also, on archive.org you'll find a ready to run VirtualBox image, so you can get started right away. Please bear in mind that I didn't invest time here to apply any of the more recent patches, so what you get is a pretty much vanilla 3.148 release of Cobalt OS. You surely want to know what I'm going to do about that bricked RaQ 3. Well, I'm still looking around if I can get the spare mainboard from somewhere. But maybe I can reflash this chip via an EEPROM burner. The only catch is it's soldered to the mainboard and not socketed, which complicates matters a bit. So, how did you like my excursion into the Cobalt OS? Let me know in the comments below. I'm the Vintage Collector and this was my story for today. Thanks for watching and see you next time. If you check out this channel's community tab, you'll find some polls on potential upcoming videos. You're very welcome to upvote on upcoming topics or drop in new ones you'd like me to chase down.